of a difference here today. So let's get started. It says, writing single transformations as compositions. Some transformations can be written as a composition. Write the single transformation as well as a composition which could result in the same image. So what is the single transformation that could result in this? First of all, tell me which one is the pre-image and which one is the image. Is the left one or the right one the pre-image?
The right.
Why is the right one the pre-image? It doesn't have those marks on it. Very good. So, yeah, of course, because you said it. So we're trying to move this triangle over to this triangle, right? So how could we move that triangle in one transformation? What could you do? Raise your hands. What could we do? Lindsay, face forward. What could you do to move this triangle on top of that triangle? If you fold it, then it will be facing the other direction.
Sorry.
Casey.
-8. And then I think the y is
8 is not enough. Try to count again. Count again. Start it.
It's 10.
It's okay.
Oh, I counted from C to B.
So it would. Okay, good. So it is a translation. It is Friday, but that does not mean you need to be doing what you're doing. A lot of you guys do not write this correctly. You need the X comma Y there with the arrow. And then we said it's X. What is it, Casey?
-10.
Goes 10 to the left, comma.
Y.
Y doesn't change. So that would be the single transformation. Now we need to come up with a composition. Which means more than one transformation. So come up with more than one transformation to get to that. What could we do? Think about it. What happens if you reflect it? What happens? It goes the wrong way, but if you reflect it again, will it be the correct way? Right? Because if you're looking at... I'm trying to think of something that's misshapen here. So, if I reflect this, it goes the wrong way, right? But if I reflect it again, isn't going to go the right way again? So 2 reflections is the same as a translation. So 2 reflections are the same as a transformation. Where did I put my stylus? There it is. So 2 reflections over parallel lines is a translation. So which lines would we use to do a double reflection? Which line would you use to double reflect it? Would it be an X equal or a Y equal?
Y.
If you do a Y equals, it goes this way. You want to do X equals -1 first? So the first one is we're going to reflect over X equals -1 and plot those points. Wait, I went the wrong way with that. No, I didn't. Yes, I did. This is what Casey told me to do. We're going from here. Just go with it.
Oh, are you moving that one?
Yeah. So, yes, we are moving the... Remember, we moved from the original to the new one, right? So this is the original, the pre-image, and then that's the image. So what's the next reflection line then? What is our next reflection line then? What's the next one? X equals what? -6. We do X equals -6. do that while I'm writing quickly, so that's not shocking that just happened. So C is 1 away, and it's 1 away again. And B is also there. So do you see how that maps onto that then? You guys see that creates that same triangle? So, who's confused? Who needs help? Or are we okay with what we just did? Did you have to choose x equals -1 as the first line? No. Could you have done like x equals 2 and then do a different line that's also parallel? Yeah.
Okay, do you have to, like, does it matter what your second, like, reflection over line is?
What do you mean?
Like, how reflection over x equals -6, does it have to be -6?
If the second one is going to matter.
Okay.
The first one won't. The second one won't matter because it has to end up on top of it. Does that make sense? So the only way to end up on top of it, that would have to matter. But the first one, you could have reflected over any of these lines and then chosen the other one. You know what I mean? It's dependent on that. Does that make sense?
Yes.
Okay. Other questions? All right, that's the first example. So let's move on to the next one. When you're ready, go ahead and flip. So some transformations can be written as compositions. Write the single transformation as well as the composition which results in the same image. So what is the single transformation for this wonderful 1, 2, 3, 4, 5? How many? What is that called when it has 5 sides? Pentagon. Good. What is the reflection, or what is the, not reflection, it isn't even a reflection, so don't listen to what I just said there. What is the single transformation? Katie?
180 degrees.
180 degree rotation. We know it's not a translation, right? Do you guys see that? So then we would look for a reflection. It's not there, right? But we do notice it moves 2 quadrants, which would be 180 degrees, and they have the same slope. 1 over 2, 1 over 2. Down 3 over 1, up 3 over 1. So they have the same slope. So it's a rotation of 180 degrees. So what could we do as a composition to do at least more than one transformation to get that on top of it? What could we do? You want a reflection, Greg? What do you want to reflect over?
The y-axis and the x-axis.
So we're going to first reflect over the y-axis. You could go either order for that, right?
Yeah.
So if we reflect over that axis, we get this beautiful pentagon in the 4th quadrant, right? That would be the first one. And then we would reflect over the, what's the other axis that we can reflect over now? Greg already said it, but I want to see if anybody else can tell me what it was. Somebody else here? Carmichael? Yeah, the x-axis, right? If we take this and fold our piece of paper along this line here, it will fold on top of it, so then you're going to reflect over the x-axis. And you'll notice then that, oh, I went the wrong way with it though. Does it matter? In a reflection, does it matter that it went the wrong way?
Yes. No.
No, because if I would have reflected this one, this still would have gone here, right? So, it would have gone this way and then that way, right? But would it still be the same thing? Sorry, I went the wrong way with this one. Reflections, it does not matter if you go the wrong way, though. Translations, it does matter. Rotations will matter as well. Okay? Everybody understand that? So if you would have done this right, this red one really should have ended up here first. And then the blue one would have ended up down here, right? if I would have done it right. All right. No. Questions there? Questions there? I want to make sure everybody has this copied down. So we can move on to the next one. I think some of you started working on the next one a little bit. You're sorry for working on the next one?
No, I said it was hard.
This one is hard. I stared at it for a while, and I was like, what is even happening here? This shape is not my favorite shape. It's just because it's like not like a, you know what I mean? It's not like perfectly even on all the sides, so it's harder to look at it. You have to like visually like rotate things in your mind to see if it will actually line up, right? Or physically rotate it, sure. You could do that too. I can't do that with my board though, so.
You can take it off.
Let's all try to rotate my board together. That will be our class project for the day.
I'll do it.
All right. So first of all, we can see that this one is not a translation. Do you guys agree on that?
Yeah.
Is it just reflecting over the y-axis? No. So if you rotate your paper so that this quadrant, the one in quadrant 1, ends up in the one in quadrant 2, you could rotate it up. Will it look the same direction then? So it's a rotation. How many degrees is it rotating? And which way is it going? Counterclockwise. So if you look at this, the slope should be opposite reciprocal. So it's up 1 over, or up 2 over 1 for the reciprocal there, right? Up 3 over 1, up 1 over 3, up 3 over 4, up 4 over 3. So are all of them opposite reciprocals of each other to get there? Is there any way we can get this to go in the same direction? Because we kind of need it to either, like, you know what I mean, be turned up and down, right? Or facing the same way for a translation, but a translation won't get us there.
Wait, what?
And we can't just use a rotation, right? So let's look at something here. Sometimes you are going to have to use reflections of y equals x. What happens with the reflection of y equals x? Who remembers what happens with that? It doesn't switch the signs, it switches the numbers. So 4, 3 would become, Rob, it is not time. 1, 4.
Wouldn't that be A, 2, 20?
B would be 3, 1. And 1, 2. You see? Now does that look like we can reflect it? Now does that look like we can reflect it? So if you are ever like completely stumped and it doesn't look like you can translate it, rotate it, reflect it to get it on top of the other one, try y equals x. Okay? You guys understand that? Like as a last resort if you're ever stuck? Just try y equals x and see if it gets it in a position that you can do something. Can we do something with this now? Reflect over which axis? So then it's a reflection over the y. Why are you dying?
Because math takes like every bit of energy out of my body.
It is a lot of work, I will give you that. So then that would end up on top of this because they're the same distance away. 1, 1, 3, 3, 1, 1, 3, 3. Okay, we only have one more example. Are there questions so far?
Rob keeps staring at me.
Because I just saw what you did.
I was dancing, and then he looks at me.
Do you see what I saw? Do you see what I saw?
It's the inflatable person in front of the carpet.
No.
Lindsay, in your hair,
That's
it
what
fell
I
out.
was talking about. Thank you.
What?
It fell out. There was paper in your hair, Casey.
Oh my God. Crazy.
Describe a composition of transformations containing two different transformations, meaning it can't be two reflections, it can't be two transformations, or it can't be two rotations, okay? It has to be one of those, which maps GEO back onto itself. So it's going to move off of itself and then go back on itself, but it has to be two different transformations. Does that make sense? So it's mapping itself back onto itself. So I'm going to plot GEO real quick. That stands for Geo. Did you guys get it? Rob, I'm just trying to make you laugh during this morning class here.
You're making Casey.
I don't think she's laughing at the fact that this spells Geo.
She keeps throwing stuff at me.
She's thrown stuff at me today too, Lindsay. You're not alone. I also feel attacked.
Casey, stop being possessed. She's getting like Satan stuff out of you.
All right. So, it can be more than one. It can be more than two compositions. You can do 3. You could do 4. Does that make sense? So it doesn't have to just be 2. If you need to do 3 or 4 to get it back to itself, you can. So give me something we could try. Let's just try something. And we'll get it back eventually. Give me anything to try. Yes. Okay. What do you want to do now? What if we translate it like down? Translate it a little bit here. How do you want to translate this? Doesn't really actually matter which way you want to translate it, but translate it in a direction. Give me a translation, Kylie. Any translation. X and what? X plus
3,
Y
6.
minus or add. Okay, so I do right 3, up 6. Why do I keep making that a Q? That's the second time I've done that. So we're not facing the same direction. So could we do another reflection to get it back to the same place? Could we do another reflection to get it back facing the same way and then another translation? Could we do another reflection? Let's try it. What if we reflect over the line x equals 1? So G would stay in the same spot, because x equals 1 is right here. E would be here. And O would end up here. Now, can we just translate it down to where it is? Can't we just slide it downwards and over a little bit? How many down does Z have to go? 6, so it has to go down 6, right 1. Do you see that? Down 6, right 1. Because it wants us to. So I'm going to do a translation.
You said Q again.
Of x plus 1, y minus 6. Of course I did. Of course I did. And that will map us back on there. Which one did I make Q, the blue one? I really just want O to be Q. That was every single time. All right, let me get you guys your homework.